When we step outside and look up at the night sky, human eyes naturally fail to perceive depth. We see a flat, two-dimensional dome, a painted ceiling of scattered lights that all appear to exist at the exact same distance from Earth. But in mid-June of 2026, the western evening sky will host an unusual gathering, a parade of planetary bodies. Venus, Jupiter, Mercury, and a young crescent moon will converge in the same region of the sky along the ecliptic plane. The display begins on June 9th, when Venus and Jupiter appear to graze each other in the twilight. Through a low-power telescope, both planets will squeeze into the same field of view, separated by just 1.6 degrees. This grouping exists only as an alignment of perspective. In reality, these planets remain separated by millions of miles of deep space void. The grazing encounter on the 9th serves as a prelude to a far more paradoxical event arriving just 8 days later, on June 17th. This top-down orbital map shows the concentric paths of the inner planets. By shifting our perspective from the ground to a point above the solar system, we can clearly see the flat disk, the ecliptic plane, where these orbits take place. As the planets race around the Sun at different speeds, they occasionally form a strict, straight-line geometric configuration. In astronomy, this rare physical alignment of multiple celestial bodies is called syzygy. If the solar system were perfectly flat, these bodies would block each other on a constant, predictable schedule. But viewed from the side, the orbital tracks are slightly tilted. Venus's orbit is angled, and the Moon's path is tilted by about 5 degrees relative to Earth's plane. Because of this tilt, bodies usually pass above or below each other in the sky. Perfect alignments can only happen at orbital nodes, the exact points where these angled paths physically intersect the main flat plane of the solar system. These alignments occur at the physical intersection of varying planetary tracks in three-dimensional space. On the afternoon of June 17, 2026, the Moon arrives at one of these nodes at the exact same moment as Venus. The foreground body, the Moon, will pass directly in front of the more distant planet, completely obscuring it in an event called an occultation. What makes this specific occultation remarkable is its timing. It takes place in broad daylight. Observers will watch a star-like object vanish behind the Moon while the blue daytime sky is fully illuminated by the Sun. Spotting a planet during the day requires extreme conditions. Venus happens to possess a hostile atmosphere, entirely shrouded in a dense, perpetual cloud deck made mostly of sulfuric acid droplets. This visualization shows incident solar radiation striking a planet's atmosphere. When sunlight hits the smooth surfaces of those suspended sulfuric acid droplets on Venus, roughly 75% of that light is scattered directly back into space. It acts as a massive cosmic mirror, making Venus bright enough to pierce the daytime sky. During this daylight event, the Moon and Venus are positioned just 38 degrees east of the Sun. Searching for them requires strict safety protocols. Observers must use certified full-aperture solar filters or stand in the physical shadow of a building to block the solar disk completely. The daytime disappearance of a planet effectively merges our local understanding of atmospheric physics with the grand mechanics of deep space orbits. As the dark, unlit edge of the lunar crescent physically swallows that brilliant point of light, the actual scale of the solar system reveals itself. The Moon sits roughly 361,000 kilometers away. Venus is 171 million kilometers behind it, nearly 475 times further in the distance. Just hours later that same day, the Moon's orbital path carries it directly across the Beehive star cluster, adding a third layer of extreme depth that sits hundreds of light-years beyond Venus. Observing the sky across that week exposes their physical distances based on apparent speeds. The Moon races across in hours. Inner planets shift night by night, while distant stars remain fixed. Observing these motions in real time replaces the two-dimensional dome with a visual comprehension of the solar system's vast three-dimensional clockwork.